Find all zeros of f of x equals x cubed minus 2x squared minus 9x plus 4. Enter the zeros separated by commas. Enter exact values using radicals and or fractions if necessary, not decimal approximations. Alright, so to factor a polynomial that is higher degree than 2, we have to find some initial zeros to start off with. Those initial zeros could be found using a particular theorem, but what I prefer is students use a graph in order to identify any zeros that they can using the graph to start with. So we begin by taking the polynomial and just drawing its graph on screen. So x cubed minus 2x squared minus 9x plus 4. To graph it, we'll make sure we're using the standard viewing window, so I'm going to hit zoom, and then the sixth item down is zoom standard, which just sets the viewing window from -10 to +10. Okay, now what we're looking for are any integer zeros, very visible integer zeros. So for instance, right here, I can pretty well tell that's going to be a visible zero that's an integer value. These are zeros as well because the polynomial is crossing the x-axis. So those are real zeros, but they're in between tick marks, and it's kind of hard to tell exactly where that's falling in between. But that's okay. Because we have a cubic polynomial, we just need one initial zero to factor out to get a quadratic, and then the quadratic we can handle using other means. So this zero looks like it's at 1, 2, 3, 4. So we'll take the zero of +4 and factor it out of the polynomial. So 1, -2, -9, and 4 are my coefficients, and I'm just setting up synthetic division here. So bring the 1 down. 1 times 4 is 4. These add up to 2. 2 times 4 is 8. 8 and -9 add up to -1. 4 times -1 is -4, and this column then adds up to 0, which tells me that in fact 4 was a 0. Had this been anything other than 0, then that tells me that I didn't actually find a 0. But we're safe here. Now, the coefficients here are the coefficients of a quadratic whose constant term is -1, linear term, so multiplied by x, is 2x, and the quadratic term is x squared. So what I need to do then is find the zeros of x squared plus 2x minus 1. And that's going to be the remaining zeros of the polynomial. Now, I could try factoring, but it doesn't look like they're pairs of values that would multiply to -1, but then add to 2. So I'm going to use the process of completing the square, which says to just take the 1 to the other side. The coefficient of your linear term, you divide it by 2, which gives you 1, and then square it. So we just add this value 1 to both sides. This now factors into x plus half of the linear value, so x plus 1 squared equals 2. We take the square root of both sides, so that's the plus or minus square root of 2, and x equals -1 plus or minus the square root of 2. So these zeros that we have, and there should be 3 of them because this is a cubic polynomial, are 4, -1, plus or minus the square root of 2.